gotta love your man. Take him by the hand.
Well, the old Seville's still going strong. Makes a nice addition to the shop to be able to play 8-track cartridges down here. Woohoo, huh? Well, let's turn our attention over here to the main arena tonight. You guys seen part 4 where we got the clock motor running on this beast of a clock radio here. And in that same video we went through and I took values of the different resistors that was in and out of tolerance and in limbo and whatnot. And marked them on the schematic accordingly. Orange is capacitors, green's the resistors. That was part 4. This isn't quite part 5, so I'm going to name it 4.5. Oh, let's see what happens with this video. Over the weekend I went down to see my good buddy Norm and took these 4 out of 5 tubes with me. I didn't have this rectifier tube with me. I must have lost my mind for a minute or two. I took these down and had them tested. Well, friends, let me tell you something. You don't tell a guy that's been in the radio and electronic TV business for 38 years that you have bad tubes when you walk into his shop. I handed these over to Norm. Norm says, well, what's wrong with them? I said, well, they got open filaments in it. He's like, how do you know that? I said, well, there's a gap in that filament right there. He's like, you can't see that? He's like, you got a tube tester? I was like, well, unfortunately, no. He just shook his head and walked away. Now, I know Norm, but I don't know Norm like a good close relative or a friend or anything like that. We're acquaintances more than anything else. We kind of kid each other around about stuff. So he took the tubes back, the 50C5, the 12AT6, the 12BA6, and the 12BE6 back, put them on his tube tester, and the results weren't as bad as what I thought. The 12BE6 showed it was leaky, and the 12BA6 showed that it was weak. All showed filament voltage. The filament lit, especially in the 50C5. After he pulled that out and put that back in my hand, it was still glowing for about 5 or 10 seconds. And I think what I am calling the filament, I'm actually dead wrong on. I'm thinking that this thing up here at the top of the tube, you won't be able to see it in the light, I know you won't. There's a little like a halo thing right here. And that's what I'm calling the filament. Well, I'm wrong. The filament's down in the center of that tube. So I need to get my facts right before I go any farther. So, what I decided to do was to stop the production, stop the show on this particular refurbishment, restoration, whatever you want to call it, and go look up on the web, how can you manually test these tubes without a tube tester? Well, I found some interesting information, and we're going to take a break for a minute, and I want you to look at some pictures that I found online of one of these 1950 Sylvania 542GR clock radios. There's actually more than just one out there. You're not a loner after all. Take a look at these pictures. I'll be back in just a minute. But that's a song you never thought you'd hear on 8-track. Top Gun soundtrack, 1986. Amazing what turns up to Goodwill sometimes. Anyway, the pictures were kind of neat, weren't they? I especially like the last two of the red one that's got the clear dial down in here instead of the gold one like this one has. I have it taken off right now, but it's gold, just like the first two you've seen in the video. But anyway, I wanted to look online and see how you manually test tubes using a multimeter. Well, it turns out there's no real good way to test a tube except for putting it on a tube tester. It's what they're designed for. But there is a way to see if you have filament, if the filament will light and glow on them. And these three tubes operate on 12.6 volts, so you do not want to exceed 12.6 volts. This one runs on 50 volts. This one, your rectifier tube, 35W4, it's a 35 volt tube. Audio output tube, like I said, 50 volt, 50C5, 12 volts. So anyway, I looked online, I come across this website, and this was electronics.stackexchange.com. I'd never heard of them before. But a guy had a question about taking old vacuum tubes. He wanted to light them up to display them, not necessarily to use in a radio or anything like that. He wanted to figure out how you could light them for display. I don't personally find that as a good idea, but whatever. Everybody's each to their own. And it says down here you could use either AC or DC voltage to power the filament of a vacuum tube. As long as you have 12 volts to light a 12 volt tube, or 6 volts for a 6 volt tube. And of course you'll have to pump up the voltage for the 50 volt and the 35 volt. So what I decided to do is download what each one of these tubes look like for their layout on their base. So what I did, I went to a website that was called, I'll find it here, the National Valve Museum. Buddy, I'll tell you what, they got all kinds of neat stuff on there. Here's the diagram and a picture of what a 35W4, this guy right here, rectifier tube looks like. Here's what each one of the pins do. 3 and 4 is our heater. These are their maximum operating conditions in volts, amps, and milliamps. Here's our 12BE6. Of course, again, we see the heater filament, whatever you want to call it, pins 3 and 4. And it shows us tolerances again. 12AT6. The heater operates on pin 3 and 4. Here's your 12BA6. The heater operates on pins 3 and 4. And last but not least, the 50C5. This was actually off a different website. This guy had a PDF version of a GE. Basically, what the limits of this tube would do, but it was designed and created by General Electric. And we look here again on the 50C5, pin 3 and 4 heater. So okay, we know what we need to do. We need to connect our voltages to pin 3 and 4 of all these tubes to make the heaters glow. Now, I already know that these will work. So basically I'm just playing around and tinkering. You know, that's how you learn. And if you want to know what any of the stuff stands for on any of these, let's take this one for example on the 35W4. What each one of these stands for, the H, the A, the HCT, the K. Some of you that's done this long enough know exactly what that stuff stands for. Someone like me that's still new, I'm learning stuff, needs to know what that stands for. H is the heater, F is the filament, HTC is the heater center tap, K is cathode, G1 is grid control, G2 is screen grid, G3 is suppressor grid, G4 additional grids used in specialist valves such as frequency changers, A is anode, BP is beam forming plates, you have your, I'm not sure what the heck they're called, like your quotation marks used to indicate electrode set, S is internal screen, IC is internal connection, TC top cap connection, and M metallized internal or external to the valve. So there we go. Now we know what all that means. Let's get down to the nitty-gritty. For this particular test, I've decided to use my wall wart that's up there into the power strip. This is the one I showed you all a while back that the voltages are all screwed up on it. Just up where you can see it. And what I mean by that, it's off right now. There's 3 volts. Okay, anyway, sorry for the interruption. Like I was showing you, that's 3 volts on this joke of a wall wart. That's 4.5 volts. That's 6 volts. That ought to be about 7.5 right there. There's 9. And there's 12. So at 12 volts, this thing will pump out a whole whopping 16.65 volts. Not good, huh? I was going to throw this away, but I thought, well, you know, it's such odd voltages, I might be able to use this for something. And look, at what's supposed to be 7.5 volts, we're actually coming in at about 11.4. That's plenty enough voltage to use for these 12.6s and not put them in danger. So let me get something rigged up here, and I'll show you what we got. Now, for me to show you what these filaments look like, I've about got to shoot in pure dark, so this camera does not hardly do that. It doesn't use any backlight, and a backlight would actually make this too bright. That's the filament of the 12BE6, under 11.47 volts on a 12.6 volt tube. So this experiment will work. That's the 12BE5. Let's move on to another one. Here's the filament of the 12BA6. Lights them up pretty nice. And after they're plugged in for a while, they actually do get a little bit of warmth to them. Not nothing overly bad that's going to burn you like when they're in the radio, but they do get pretty toasty. And here's our 12AT6. They all seem to light about the same brightness. The camera really doesn't do them much justice. Don't know how well it'll show up, but there's our very undervoltaged rectifier tube. That's only running on about 18.6 volts, and it should be running at 35. So I won't run it like that long, but you can see that the filament will light in it. The 50C5 I'll put on next, but you can just, I mean, barely make it out. It just looks like cigarette ash glowing after it's been not, you know, you have to draw on your cigarette for a while. It turns kind of like that real light cherry red color. I'll hook it up next. Now it may take a few minutes to light it because, like I said, we're severely undervoltaged here. And then I get done here, I'll show you how the tube layout, the pin layout on the bottom of these tubes works, because I never knew exactly how they counted until tonight. I didn't know if it was one started in the lower right corner or lower left corner. But I'll show you here in a minute. Like I said, this guy here will just barely light. Actually, the tip will turn kind of a whitish looking color. Just barely see it there. It's about 18 volts. Okay, anyway, let me turn the light on here. Ugh. Show you how these pins are counted. Now on the bottom here, on these particular ones, there's 7 pins. That way you can see that. 1, 2, 3, 4, 5, 6, 7. And they count this way. They count clockwise. I didn't know that. Like I said, there again, there's a lot of people out there in the YouTube community that do this quite more often than what I do, and they'd know that like the back of their hand. But you count your pins clockwise. So now that we know that all of our pins are, or all of our pins, I got that on my mind now. Now that we know that all of our tubes are good, and like I said, that doesn't that's not trying to test them like a normal tube tester would test them. I just will basically show you that the filaments glow, that they're okay. And like Norm said, even though they might not be up to snuff, like this 12BE6 is leaky and the 12AT6 is weak, that's no reason why in series they shouldn't light the filaments inside of these tubes. So the next step of what I'm going to do is look down inside these tube sockets, because some of them fit kind of sloppy, and see if there's something down in there like corrosion, maybe a tube socket, the pins have kind of opened up a little bit, they're not all making good connection. Go down in there and we'll clean that out real good. I got some pipe cleaners here today. I'll try to take some pipe cleaners and clean that out down in there and see what we got. And after that, what I'm going to do is pull these electrolytics, because they're way overvalued, and put the proper ones back in. And then we're going to start popping some of these resistors out that are not testing correctly. And we'll have that in the next video, which will be part 5. Thanks for watching, guys. I'll have more to come later. Oh, sorry to come back on short notice, but I learned something else I thought I'd share with you. I've bought both my isolation transformer and my variac off of a company called MCM, and they deal with a brand called Tenma. It's a house brand. This is actually the third one of these I had, because the paint was just absolute crap on it. It seems to operate just fine. The variac, it's a little rough around the edges. I mean, it's not physically damaged like this was, but I noticed something else that's kind of peculiar about this piece of equipment, and I don't know how many of you guys actually test the voltages coming out of your variacs or anything like that, but let's go ahead and turn it on. I'll show you what I'm talking about. Okay, we're at 0. My flashlight go. We're at 0, so we read 0 volts. Okay, there's 20. Let me read about 19. Go up to 30 here. Let me read 30 volts. 40. We're starting to grow. We're 43. Okay, there's 50. We're at 58. Let's get back here. At 65, we're running about 67. I'm up to 80 volts. You can see we're showing 92. There's about 90 volts, and we're sitting at 100. At a whole whopping 100 volts, we're reading 110. I'm going to max this out and show you that that dial goes to 130, and the voltmeter reads 145. So I'm going to have to be really cautious with this variac. Now, it's accurate up to about 40 volts, and after that it just goes to crap. It starts gaining 2 or 3 every 10, and then by the time you make it up to 100, it's actually gained 10. So 100 is actually 110 volts, and 130 is actually 144 volts. And I tried bringing it up slow. I thought maybe I brought it up too fast, and something weird happened, because I don't have any experience with these. This is my first variac I've ever worked with. But I brought it up slow, let it sit and stabilize for a minute, and same deal. So just to throw that out there, anybody that has one of these units, be kind of gun shy of it, because it's putting out more than what it's showing on the dial scale back here. So I will do something about that. I'll put a piece of paper over top of that or something, and make a notation somehow to that that's not correct. So I just thought I'd pass that along, guys. So this time I'm gone. Thanks for watching.